Welcome to the shop. I'm continuing NQALHA production run number 4, and today I'm going to be making part number 103, which is the dual motor end plate. And I'm going to be leaving out a lot of the setup steps. I went over the setup of the machine in great detail in the first two videos, and after having done that, I don't think I'm going to repeat myself. So the machine has been set up. This is a more normal setup. Most of my parts that aren't really big, that fit within one vise, most of my parts, the first operation is done on the right vise, second operation is done on the left vise on a tooling plate. So I've already used the Heimer indicator to set my 0 points for work offset 3 and work offset 1. And I've got my known trusted tool path. This is a tool path that has made many parts in the past, so I have a pretty good confidence that it's going to work. And I've got my setup sheet up here, and going to be making this 5.92 by 3 by quarter is the stock. And as usual, I make it a little oversized, might as well be careful. And also, as usual, using aluminum extrusion. Okay, that looks good. Using aluminum extrusion cut on the cold cutting carbide chop saw. Before I forget here, I'm going to adjust my stop. The saw didn't come with a stop. I had to make one, but when in production, it sure makes things a lot more convenient. So, a little quick deburring on the Scotch-Brite. Go over here and get the part in the vise. The first part that I make, I'm just going to do the first operation. Then I'm going to put the first part on the tooling plate, load up a blank in the vise, and do a combo tool path that does the first operation and second operation in the same machine cycle. So, got the program loaded up, got all the tools loaded up. All the tools are prepared in the tool carousel, and my standard operating procedure is always treat a tool path as a new tool path, even if it's an old trusted tool path, if I haven't used it for a long time. Because, as I pointed out in previous videos, memory can be faulty. Been a long time since I made these parts, and even though I kind of remember how to do it, there were probably a few little special things that happened, a few little oddball things that didn't get written down. And so I'm going to have my finger on the stop button, and as soon as the tool gets loaded up, going to put it into single step mode. Verify that it stops an inch or so above the surface. This programmed stop is put in there by the toolpath program, probably for this purpose, probably as a sanity check. So that looks fine, and that looks fine, and this is 5,140 RPM, 10 inches per minute, using the fast peck cycle, and I think, if I remember right, 60 thousandths per peck. And once again, I choose my peck cycles, feeds and speeds, and peck distance to minimize rat nest buildup on the tool, and to try to get good chip braking and good chip control. So things are looking good so far. The tool is more or less clean. It does have, can't touch the machine while it's working. It does have a little bit of a chip buildup, but nothing dangerous, nothing that is going to bother me. So verify pre-feed correct, verify feed correct, and at this point, I'm pretty confident that I can just let it run. Because like I said, it was a trusted program that had made many, many parts in the past. So I think the next one, I'm just going to let it run. Still have my finger on the stop button. And some of these holes are pretty close to the edge. I don't believe any of them are actually intersecting the ledge of the soft jaws. And, this is interesting. I didn't load all of my tools. I'm missing a tool. So I'm going to load tool number 26 manually. Don't usually make that mistake, but it's a nothing mistake. It doesn't matter. It wasted a few minutes. Maybe not even a minute. Maybe just a few seconds. So now I'm switching to the aluminum shredder roughing bit from Lakeshore Carbide. And this one is a serrated flute, 3-flute solid carbide roughing cutter that produces really, really small, fine chips that are very easy to evacuate using the flood cooling. And I like to use both a roughing pass and a finishing pass, even though I could probably get away with just doing the whole thing with the finish cutter. But the roughing cutter takes a little bit of the abuse, and because I'm doing it in 2 passes, I'm not using the full flute length of the cutter, and so I'm getting uneven cutting wear. And if I did that with my finishing cutter, I'd end up with the tip of the cutter being worn more than the piece up above. What I'm doing now, the finishing cutter is not really doing much work at all. It's just barely touching the surface, and it's milling the entire thickness of the parts. So now I'm getting a tapping operation going, and let me be a little more careful about that. Looks like the pre-feed is correct. I manually inserted, I turned off the flood coolant and manually inserted a pause operation so that I could apply Tap Magic cutting fluid. Tap Magic for aluminum does a really, really good job. And I've had trouble in the past using this, the compression tension, Tormach compression tension tapping head. It's so long that if I tried flood coolant, well, the flood coolant just hits the body of the holder and doesn't actually get on the tap itself. And also, I don't think the coolant does as good of a job. So I throw in a manual pause, and let me get my tool correct here. So I'm gonna load up that tool, get that correct. Okay, so now I've got my first of the first operation parts, and I could take the time to deburr it before loading it onto the tooling plate, but that would just slow everything down, so I'm going to put it aside for later, go back over to the chop saw, using WD-40 as a cutting lubricant. The blade on that thing produces a nearly burr-free cut. It's a special aluminum blade, so I almost don't need to deburr it, but hey, why not? So the tool path is now proven. I'm totally confident it's going to work. I can basically walk away, do something else. So I'm going to use the Noga hand deburring tool. A lot of holes. So this is the plate that the motors mount to, and I thought, well, might as well just do a quick sanity check, go get a motor, and kind of do a little eyebolic examination and verify that, yep, looks good. So always nice to Double check, triple check, check again, check the check. I'm cutting the cutouts here, the profiles, in 2 passes, and I probably could cut it in 1 pass, but when I try pushing the machine, I end up with chatter. The machine is mostly limited by tool holding force. The automatic tool changer, the power drawbar, is a somewhat limited design, and if you try cutting with too much, try cutting too aggressively with a spiral cutter, you end up pulling the tool holder out of its collet. So tool holder retention, machine rigidity, which leads to chatter, are the primary reasons that I can't do really aggressive cutting. And then the secondary reason is that it's only a 1.5 horsepower motor. So I understand that a more rigid, more capable, more powerful machine could probably make my parts a whole lot faster. You know, this is what I've got. So now I'm going to go over to the tooling plate here and line up some of the screws. I've got slightly inconvenient here because the mounting holes are 2 different screw sizes. I use a very tight clearance hole in my through holes, much tighter than the standard charts recommend. And because I do that, I can use my holes. These are actually holes that are in the part for reasons having to do with the part design, that I can use these holes in the part as alignment holes in the tooling plate and get a very good precise alignment. Of course, the outside perimeter of this part is non-critical, and it could be off by a few thousandths, but it probably won't be. It'll probably be quite good. So now I'm going to load up what I call the combo tool path that does both of the first and second operations. And once again, the combo is a known trusted tool path, but I'm going to treat it like it's a new tool path because I haven't run it yet today. Pre-feed looks good. Okay, that's enough sanity checking for me. I'm confident that the first half of the first operation is going to be okay. So, back to the Noga. And yeah, I probably could chuck one up in a cordless drill, but it really doesn't bother me. A lot of holes in this guy. I try to get a lot of things done in parallel. So, cutting blank, deburring blank, deburring part, and eventually, as the process proceeds, I'm going to be doing the third operation on the Bridgeport, all while the machine is busy. So I'll be doing as many things in parallel as I possibly can. And all is looking well. I'm a tiny bit annoyed at Tormach, actually. And it's not their fault, but it's just bad timing on my part. Just a few months after I bought my machine, they came out with the new machine, which is substantially better, and at least at the moment there is no upgrade path. So, kind of unfortunate. If I decided to sell this thing, I'd be competing with all the other Tormach owners who have the old generation, all trying to unload them, and I suspect that the value on the used market wouldn't be that good because of the abundance of these machines and the fact that the new MX machine appears to be very superior in almost every way. Of course, if I could figure out how to get it through the garage, I might just upgrade to a Haas mini mill, but it doesn't quite fit in my space, and it certainly wouldn't fit through the garage door. And it costs about twice as much. But I'm a tool junkie. I love tools. About the only thing I spend money on. Even though the compression tension tapping head is a kind of a workaround for a marginal design, no, it still works well for me. Okay, so here comes a part of the tool path that I have to consider as new because I haven't run it today. And it's at the correct work offset, the correct Z height. Everything looks sane. And yes, it looks like it's operating correctly. So I can now go into production without having to be, well, actually, let me check the finishing pass and verify that before I say it's okay to kind of stop paying as much attention. Even when I have everything dialed in, I don't like walking away and leaving the room and leaving the machine unattended. Things can happen. I've had problems with my CNC wood router where all of a sudden it just got confused and kind of forgot where its Z position was. So, verify pre-feed, verify feed, and looking good. Adding the finish cycle, the finish tool path, really gives an excellent surface finish. And even though, you know, people buy my machine because of its utility, my customers are artists, and I'm pretty sure that they appreciate a beautiful machine. And so I take a little bit of extra care. Try to make it look as nice as I can. And there we have that. Let's clean the tooling plate. Get my screws in place. My next blank in place. You notice that I'm not using the mallet to hammer the blank down onto the jaws. I'm drilling holes in it. The Z surface doesn't matter. It's not critical. If I was making a part where the Z height needed to be within 1/1000th, yeah, I'd use the mallet. So, toolpath is under control. I can get this guy and take him over to the Bridgeport. And then this hole doesn't need to be ultra precise. And I have a really good eye for perpendicular, so I can pretty much tap a straight hole by eye. Not only by eye, but by feel, because I can feel the tap align itself. But, you know, having said all of that, if I really care and I really have a part that needs to be perpendicular, it'll be machine tapped or tapped with a tapping guide. Giving it a little bit of a Scotch-Brite. It's going to go in the vibratory finisher, the vibratory polisher, but this one had a particularly large amount of paint on it. And so anyway, that's what the part looks like. Machining is complete on that guy. I'm going to put it over in the pile of finished parts. Get to work with the hand deburring tool. Turn off the camera because from this point on it's all repetitive. And then probably, I don't know, there's no need to show the vibratory polisher. I showed that one in the last video, so I think this is the end. Thank you for watching.